Hello dear students, in this session we'll try to prove the law of conservation of mechanical energy in terms of a freely falling body. Okay, so this is a usual important question in the case of your board exams. In board exams, usually this question is been asked for 5 marks. Okay, the question is something like this: state law of conservation of mechanical energy and prove it in case of freely falling body. Okay, the statement of law of conservation of mechanical energy, we have seen it already. Total mechanical energy, okay, the total mechanical energy of a system is conserved if the forces doing work on the system are conservative. Okay, for the definition of conservative force and all, just refer the previous video. What is mechanical energy? Mechanical energy means sum of kinetic energy plus potential energy. Okay, so we have to prove it in the case of freely falling body. We'll do it. Say this is ground. Okay, a ball, okay, of mass m is dropped. It is dropped. Dropped means what is initial velocity? Initial velocity is equal to 0 from a height h. I'll take it as capital letter H. Okay, say this point I call it as A, and the ball comes down, potential energy decreases, kinetic energy increases. I consider one more point B here. Okay, one more point B. This point B, say it is at a height of small letter h. Okay, then this ball comes down, reaches the ground. Okay, this point I call it as C. Okay, the distance traveled by the mass in coming from A to B will be distance traveled will be h minus h. Hope you can understand. H minus h. Okay, clear? Now what we have to do? Proof means what we have to do. At point A, we have to calculate kinetic energy plus potential energy. At B also we have to calculate kinetic energy and add it with potential energy. At C also we have to do the same. And we should prove that at all the points, sum of kinetic energy and potential energies are equal. Okay. At A, so first we'll consider the point A. At A, what happens? At point A. At point A, what is kinetic energy? Kinetic energy is equal to 0, na? Kinetic energy is 0 because ball is being dropped. Kinetic energy is 0. Okay. What is potential energy? Potential energy is mg into h. mgh, correct na? Because it is at a height capital letter H. So therefore, what is mechanical energy? Mechanical energy, total mechanical energy, E is equal to kinetic energy plus potential energy, 0 plus mgh. Okay, so kinetic energy plus potential energy, 0 plus mgh will be equal to mg into h. So this is my equation number 1. Okay, at point A, what is the total mechanical energy? I have calculated. That was very simple. Now, at point B, a little tricky. Okay, at point B, okay. What is kinetic energy? Kinetic energy is equal to half m v square. This is the formula. Half m v b square L rate. Velocity at point B. Okay. So kinetic energy is equal to half into m into. Now here I'll show you a small calculation. Okay, if you use v square is equal to u square plus 2ax formula, okay, velocity at point B whole square, vb whole square is equal to initial velocity. What is initial velocity? Ball has been dropped. Initial velocity is 0 plus 2a into x. X means what? Distance traveled by mass. Okay, distance traveled by mass is how much? This, correct na? What is that? H minus h. H minus h. Okay, sorry. H minus h. But what is A? A means acceleration due to gravity. G, correct na? In the place of A, I will be writing G. Okay, 2g into h minus h. So since the ball is coming down, distance is negative and g is always negative. So negative, it becomes plus here. So vb square equal to 2g into x. X means distance traveled. Distance traveled by the ball is h minus h. So half m into Vb square. What is Vb square? Vb square is 2g into h minus h. 2g into h minus h. So what happened? This 2 and 2 gets cancelled. So kinetic energy will be equal to mgh minus mg into small letter h. Kinetic energy is mgh minus mgh. So kinetic energy we have calculated, correct now? Now we calculate potential energy. What is potential energy? Potential energy at this point is equal to mgh formula. mg into h. Now small letter h because ball is at point B. So the height is small letter h. Okay, potential energy is mgh. So therefore what is total mechanical energy? Total mechanical energy is equal to kinetic energy plus potential energy is equal to, so what happened? mgh minus mgh plus mgh. mgh minus mgh plus mgh. So mgh with the small letters gets cancelled. So we get total mechanical energy at point B. I'll write this as total mechanical energy at point A. Okay, is equal to mgh again. Correct now? So this is my equation number 2. At point A also mechanical energy is mgh, B also mgh. Okay. Now the last point. At point C. What is kinetic energy? Kinetic energy is half m into v square, vc square, velocity at point C, just before it hits the ground. Okay, so kinetic energy equal to half into m into, so using the formula v square is equal to u square plus 2ax. Okay, or I'll write it here. Vc square is equal to u square means 0, initial velocity 0, plus 2ax, 2 into g into distance traveled by the ball on reaching C will be equal to h, correct na? H, 2gh. So Vc square is equal to 2gh. Half m into Vc square is 2gh. What happens? 2 gets cancelled. Kinetic energy is equal to mgh. Kinetic energy is mgh. What is potential energy? Potential energy, since the ball has reached the ground, height is 0, potential energy is 0. So therefore total mechanical energy at point C is equal to kinetic energy at point C plus potential energy is equal to mgh. So this is my equation number 3. So then what you have to do? You have to write over. The derivation is over. Okay. So we have already proved that at point A mechanical energy is mgh, at point B mechanical energy is mgh, at point C also mechanical energy is mgh. So therefore in the case of gravitational field, in the case of freely falling body, the principle of conservation of mechanical energy is proved. Okay, from 1, 2 and 3 we see that total mechanical energy is conserved in case of freely falling body. Now we will solve 2 problems related to law of conservation of mechanical energy. Okay, a rubber ball falls on a floor from a height of 19.6 meter. Calculate the velocity with which it strikes the ground. Okay, to what height will the ball rebounds if it loses 25% of its energy on striking the ground? Okay, height is 19.6. Okay, I'll solve it here. A ball is dropped, a rubber ball is dropped from a height of 19.6 meter. Okay, the ball will hit the ground and it will rebound. Okay, to a height, to a certain height. What is that new height? That height also I have to calculate. Okay, and one more thing is I should calculate the velocity. Calculate the velocity with which it strikes the ground. Okay, that is the first subdivision. First subdivision, I should calculate the velocity. Okay. So here what is happening? Potential energy is getting converted into kinetic energy, correct now? So half mv square is equal to mgh, gets cancelled. V square equal to 2gh, v equal to root 2gh. So we get the velocity. Okay. So 2 into g is 9.8, h is 19.6. Why have taken g 9.8? Because they haven't mentioned that you have to take g is equal to 10. So you take the proper one. And one more thing is, since h is 19.6, it becomes easy for you to calculate. 2 into 9.8 is 19.6. Okay, so square root of 19.6 into 19.6 is 19.6 only, correct now? So V is equal to 19.6 meter per second. Okay, so first subdivision is over. Second subdivision, what is second subdivision? When the ball hits the ground, the ball will rebound. If it loses 25% of its energy, while rebounding, it loses 25% of the energy. Now, to what height the ball will rebound? Okay. Okay. So here, what I'll do in the first subdivision, I'll take this as mg h1. Okay, h1. Right. Now, okay, mgh2 is therefore mgh2. So what is this? This is h1. I have taken h1. What is mg? This is h2. Okay, mgh2 is equal to, the ball loses 25% of the energy, means 75% is remaining, correct now? Is equal to 75% of mgh1. 75% of mgh1. So what happens? Mg and mg gets cancelled. So h2 is equal to 75 by 100, means it is 3 by 4 into h1. What is h1? h1 is 19.6. Okay, so h2 is equal to, so 4 goes 5 times in 20. 5 into 3 is 15. So this is just less than 15. Might be 19.6. This is 0.13. Okay, yeah, this is 14.7 meter. You can use the calculator. So the answer is 14.7 meter. Hope you can understand. So it has lost some energy, correct now? 25% of the energy is lost. So how much? Initially the ball had an energy equal to mgh1, correct now? mgh1. So 25% is lost. What is remaining? 75% is remaining. So mgh2 is equal to 75% of mgh1. So you got the height also. Okay. Next, this problem is for you. This is not based on mechanical energy. This is a simple calculation of work done. A body constrained to move along z-axis is subjected to a force F is equal to minus I cap plus 2j cap plus 3k cap Newton. What is the work done by this force in moving the body over a distance of 4 meter along the z-axis? Means displacement is 4k cap. So work done is equal to dot product of force and displacement. Correct? Now use this and solve the problem. Solution should be in the comment section. Okay. Next. The bob of a pendulum is released from a horizontal position A as shown. Okay. So there is a pendulum. It is stretched along the horizontal. Okay. Now it is released. So the bob will come like this. Okay. If the length of the pendulum is 9.8 meter, what is the speed with which the bob arrives at the lowermost point? Okay. So what is happening here? Potential energy of the bob is getting converted into kinetic energy, half mv square. Correct now? Potential energy at point A is equal to kinetic energy at point B. It is getting converted. So m and m gets cancelled. So what is the speed? Okay, v square equal to 2gh. V square equal to 2gh. V is equal to square root of 2gh. Okay, so v is equal to square root of 2 into, okay, g is 9.8. So same numbers, and h is, what is height? Okay, height is 9.8. Height is 9.8. So so now calculation is difficult, but square root of 9.8 into 9.8 is 9.8 only, correct now? So root 2 into 9.8. Root 2 is 1.4. 1.414 into 9.8. Probably it will be somewhere around 13. Okay, so root 2 into 9.8 meter per second. So these are the two simple examples. Next, in the next session, we are going to discuss motion of a body along a vertical circle, which is very, very important for NEET and JEE. Thank you very much.